All right, so section 3, we are dealing with function compositions. So this is similar to stuff that we've done with evaluating functions because a composition of functions takes two functions. One of them becomes the input of the other function. So as I go through this, you should start to see. If not, I can clarify in class. Always evaluate the compositions of functions from right to left. So I will talk about that here in a moment. So in example 1, it says given f of x is 3x plus 1, and g of x is x cubed. Find each value. So part A, they say f of g of 2. That is how it's read. So you read it left to right. So f of g of 2, what we have to do is we have to put the g function inside of f. So we are replacing the x values with the entirety of the g function. So let me get my pen out here. And so we write f. So every time you say x, I want you to write parentheses, just kind of like we were doing with function evaluation. So 3x, so there's the parenthesis. You want to give yourself enough room so you can put g in there. And then plus 1. So that would be function f, 3x plus 1. And now we're going to go ahead and we're going to toss this x cubed inside every parenthesis that you wrote. In this case, it's just the 1. So now we can simplify just like we did in class for section 1 and section 2. So 3x cubed plus 1. That's going to be our final answer for that part. Now, we have this 2 still. So this 2, we know from function evaluation that that is an x value. So we're going to go ahead and plug that in to the function. So 3 times 2 cubed plus 1. So 2 cubed is 8 times 3 is 24 plus the 1, so that would be 25. You could write it up here too. F of g of 2 equals 25. So that's our answer for the first one. Okay, so hopefully you're catching on a little bit. If not, give us some time. So the next one, this is another way that function composition is written. So here's the first one in part A, and then here's the second one. So this is still g of f of 2. So keep in mind that this open circle here means function composition. It does not mean multiplication. And we'll talk about the difference once we get to multiplication. So g of f, so I'm going to write g first. And remember, anytime I say x, we're going to put parentheses. So x, so we're going to throw f inside for the x. And then that's cubed. Do not forget the cubed. So we could multiply this out, 3x plus 1 times 3x plus 1 times 3x plus 1, but we don't need to do that because we are evaluating. Now, if we wanted just the function, we would want to multiply it out. But I'm just evaluating 2 in for x, so we can just go ahead and replace the x with 2. And we could have done that in the first step too. Once you get comfortable, you can go ahead and do that. So now we just evaluate. 3 times 2 is 6, plus 1 is 7, and then cube that. So let's think. 7 times 7 is 49, and then what is 7 times, 49 times 7. So let's think about that for a second. So that should be 343. Right? Because you could, basically, so this is another strategy that I teach for multiplying in your head. You have a 49, which is super close to 50, And we should be able to count by 50s pretty easily. We know 6 50s makes 300, and then a 7th 50 would be 350. Well, 50 and 49 are one apart from each other, and I did 7 of them, so we take 7 off of that, and we get 343. So I'm going to be using that strategy quite a bit this year, so hopefully you'll pick up on it if you just didn't get that rambling real quick. But here's the answer, so 343. So now we have f of 2. So now I'm putting f inside of f. So we have 3 times x, so that's where we're going to throw the f in, the whole thing, and then plus 1 on the outside, because that's still the original f. So we could simplify this to 9x. 3 times 1 is 3, plus 1, that would give us a positive 4. And now we can go ahead and evaluate it at 2. So 9 times 2 plus 4. So 9 times 2 is 18, plus 4 is 22. And there's our answer. So go ahead and pause and do the checkpoints, and then I will go over these. So the first one, f of g of 9. So I'm going to speed up the process a little bit. I'm going to throw the number that we are evaluating in right off the bat and go from there. Saves us a little time. You'll see what I'm talking about. So f first, so 2x. And remember, g goes inside, so the function g goes inside of here. We close the parentheses off, and we still have that minus 3 that we got to throw on there. Now, I left that open so we could put the the number we are evaluating in. So the 9 goes in x's place. So now we just simplify. We don't have to do any distribution or anything like that. So square root of 9 would be 3 plus 2. That'd be 5. So 5 times 2, that would be 10 minus 3. So we get an answer of 7. And then the next one, g of f of 3. So g is written first, so we have the square root of x. So remember, I'm making it a little bit bigger because I have to put our x is now f. So 2 times x minus 3. And if we look up here, this is our x value, 3. And then we have to put this plus 2 at the very end. So now we just multiply it out, do order of operations. So inside parentheses, 2 times 3 would be 6, minus 3 would be 3. And now we have square root of 3 plus 2 on the outside. So if you remember radicals from Algebra 1, we cannot combine a radical and a regular number together. This is the answer. This is the way we are going to leave it. So square root of 3 plus 2. Okay, well, we could throw that in the calculator and get a decimal answer, but we don't need to. So now example 2, we're given f and we're given g, and then we are asked to do f of g. So g, this entire function goes inside of this x. So 5 times 2 all over x minus 1. Now notice that we don't have a value to evaluate. We just have an x. So our final answer should be a function with x in it. So there's 5 times our x, which is now the g function. And then we're going to add 2 at the end. Now we have to clean this up. So if I multiply a fraction by a whole number, we know that the whole number just multiplies to the numerator. So 5 times 2, that'd be 10 all over x minus 1, bottom does not change, and then plus 2. And we're just going to leave it like this. I mean, we could add these together, get a common denominator, but it's completely unnecessary. This is a good answer, this right here. Now g of f, so we're going to plug in f inside of g. So we have 2 all over x, which we know is now the f function, minus 1. So that is underneath 2. Now we can simplify the bottom a little bit, but can't do a whole lot after that. So 5x plus 2 minus 1, well, these go together. These are like terms. So the parentheses in this case are kind of unnecessary. But I want you to be in a good habit. So 5x plus 1 all underneath 2. That would be your answer. Now f of f, we're taking this f function and we are throwing it into the x for f. So we get 5 times 5x plus 2. And then that plus 2 from one of the f's has to go outside. So now we can clean it up a little bit. Distribute the 5 in. So 5 times 5x would be 25x. 5 times 2, it's 10. And then plus the 2, that would give us 12. So 25x plus 2 is the final. So here's your checkpoints. Go ahead and pause. Make sure you're doing it right. So f of g of x. So same thing. Let's plug in g into the f function. So 3x. So here comes our g. Sorry, I'm moving the mouse a little slow tonight. And then minus 4. And now we can distribute here. So 3 times the square root of x, and this is how we write it. Just 3 on the outside of the root. So 3 root x is how you say that. 3 times 2 is 6, and then we're going to take away the 4. So we end up with a positive 2. And that's our final. 3 root x plus 2. G of f of x. Now I'm taking the f and we're putting it inside the g. So we kind of did something similar to this in one of the examples. So there is the 3x minus 4. And that is underneath the root. There's nothing else under there, so I'm not going to write parentheses. And then the plus 2 is on the outside. Whenever you're doing problems like this with square roots and you have numbers on the end, make sure it's clear that the bar doesn't go all the way over or like halfway over. We don't want to confuse anybody, especially me when I'm grading things. Okay, make sure it's clear. You may want to leave a little gap in here. All right, example 3. So tables give selected order pairs for functions f and g. So we're doing the same thing that we did earlier, just with tables. So find each of the following. F of g of 2. So on this, I'm going to change it up a little bit. I want you to work inside out. So right to left. So g of 2, if this f were not there, and I told you to evaluate g of 2, you know how to do that. We worked on that the other day. So g of 2, we go up to this chart, this table, and we look for the x is 2, and what is the y value? So the y value is 3. So what we're going to write is we're going to write f that's still out there, can't just get rid of it. So this g of 2 we just said was equivalent to 3. So I'm going to replace it with what it equals, is 3. So now you can do this. You know how to do this. 5, f of 3. So we're going to go over to this other table that has the f of x in it. Okay, don't get confused on that, or don't mess that up. So we looked at the, where is 3 on the x? Here we go, right at the end. And then what is the y value? The y value is 9. So 9 is your answer. Okay? Once you get used to it, it's a pretty simple process. So now we look at g of 1. So I have this f still here, so I'm just going to drop this down. And we're going to focus in on g of 1. Well, g is on this table. So 1 is the x. What is the y? Well, it's 9. And now we can evaluate f at 9. So x is 9, and the y value would be 6. So there's our answer. F of 6. So f over here, x is 6 here, and then the y value is 7. So we're going to evaluate g of 7. So the g table is over here. Look for 7. What is the output? That is a 4. All right, go ahead and pause and try these. All right, we're back. And f of g of 5. So g of 5, what is, g of 5. So go to the g, 5 is 6. So we are doing f of 6. And then 6 on the f table would give us an output of 7. And then looking here, f of 9. F9 right here. So 6 is the y value. So we have f again, so we're looking for a 6 on the x, and then the output is 7. And that's it. Okay, looks like the last example here. So example 4 is evaluating functions given a graph. So it's something similar that we've done this year already. We evaluated a function with an actual function written out, and then we had tables, and then we had graphs. So we've already kind of done this. It's just looking at it 2 times in a row with the function composition. So the graph of the equations f and g are shown below. Okay, so g is this line, and then f is this upside down parabola. Which of the following best approximates the value f of g of -1? So remember, we're going to evaluate g of -1. So we go to -1 on the x, and we look where it hits the g function, which is the line. So we're right on it. So y is 0. Okay? So we now need to evaluate f of 0. So go to 0 on the x, which is here. The f, remember, is the parabola. So we go here, and it is a output of 3. And then the next one we need to look at is g of f of -2. So we are, again, looking in here, f of -2. -2 on the graph, and then the f function, which is again the parabola. Don't mix those up. We have an output of +2. So +2, and now we can evaluate the g at 2. So go to 2 on the x, and then go up to where it hits the line, because that's the g function, and we get an output of also 3. All right, go ahead and pause, try it. All right, graph of the equations f and g are shown, just like the one above, and then you had one to do, where you're looking for an approximation of this. So g of -4, g is this v shape, which later on we'll talk about is an absolute value function. So g of x evaluated at -4. It looks like it crosses right there. So the y value for this is 0. Oop, I got that backwards. F. So now f of 0, we go to 0 and see where it hits the line. So it looks to be about -1. All right, that wraps up section 3. Go ahead and try the homework.